In this video, we will be looking at this function. We'll be finding the domain, we'll be finding the range, we'll be finding where f of x is positive or y is positive, and where f of x is negative. So let's go ahead and we're going to start with the domain. I'm going to get my ruler. There we go, that's close enough. Now I like to move it from left to right to just kind of give us a visual what this, when the x values start getting hit. And so we can imagine this graph going on and on in this way. So as we start moving, we know we're going to be hitting x values. They might be really, really low, very, very small values, but we're going to be hitting them as we go on. So we can see we start at negative infinity. Similarly, as we move on, it will go to positive infinity. Now, as we write that, we're going to write this in set builder notation, or also referred to as set notation. And so the way that we would write that is x such that, so we do our little squiggly line, x such that, and then it's just negative infinity is less than x is less than positive infinity. So just like that. Notice we don't have it equal to infinity on either side. We can never equal infinity. It's something that's just going on forever. And so it's always just going to go, we'll just say it's right up to infinity since that's a number that's constantly going on. Let's go ahead and write it in interval notation just so we can see what that looks like. So we'll have it from negative infinity to positive infinity. Again, we don't want to include either of those, and so we'll just have them in parentheses. Okay, let's do the same thing with range. So we'll be taking this, our ruler, and moving from bottom up to top to see which y values we're going to hit. Well, you can see it's really kind of similar as we move up, or even as we're at the bottom, we can imagine that graph going on forever and we will be hitting those y values right away. So we move up, now we can actually see it hitting the y values, and we can see this is the last y value we'll hit where y equals 3. Once we get above that, we're not hitting y values anymore. So for that one then, the range is just going to be, we'll switch this and do this in interval notation. So we can see our least is negative infinity. We'll just have a parenthesis there, and it's going up to 3. Now we do want to include 3, and so we'll have it equal to 3 so that that number is included in the range. If we were to write this in set notation, we'd have x such that negative infinity is less than x is less than or equal to 3. So you can see we're just writing this basically as an inequality, and that's how you do that set notation. Okay, let's next look at where f of x is positive. So really we're looking for where are there positive y values. We know the positive y values are only going to happen above this point. This is where y is 0, so only up here 1, or let's see, that would be 1, and then 2, 3, 4, those are our positive y values. And so we can see this function is only positive right here for these values. So we want to give the interval that this happens in, and so we can see that would be right here from -4 to -2. So where x equals -4 to -2, f of x will be positive. Now we do not want to include -4 and -2. Because at -4, for where x equals -4, y is actually 0. And so it's neither positive nor negative, and it's the same at -2. Y is neither positive nor negative. So we'll just say where x is -4 to -2, or not just up to that point, that is the interval where f of x is positive. So let's start with this one in set builder. So x such that, in fact, it might be good to pause the video and try it by yourself just to kind of check if you're getting it. So we want to say -4 for our lower bound is less than x is less than -2. So this is the interval that those y values are positive. If we want to put it in interval notation, we'd say, okay, we want it just from -4 to -2, and we don't want to include either of those values because y equals 0 at those points. Okay, last, let's go ahead and look at where f of x is negative. So f of x is negative down here. We can see these are my y values that are negative. So I can see this graph is going to be negative here, and it's also going to be negative right here. And so the interval where that's true is right, this is my cutoff. Again, that -4 is the place where it goes from negative to positive. So I can see from -4 down to -infinity, I'm going to be negative y values there. Similarly, I can see right here from -2, this point, to -infinity, I'll have negative y values. So pause this and try to write that in interval notation, right? What you think that would be. Okay, so let's go ahead and look at the interval notation. This one's a little different because we do have two intervals. So for this first one, we'll have -infinity up to -4. We don't include -infinity, and we also, again, are not going to include -4 because it's neither positive nor negative. Now we're going to have our little or sign in between. So it's this interval or -2 to positive infinity. So basically what we're saying is the only places that this function is not negative is between -4 and -2. So everything else on either side of that. Now, if we were going to write this in set notation, we'll still have our beginning x such that, and then we'll write two inequalities. So first, -infinity is less than x is less than -4, and usually they'll have you do a comma in between. So, or -2 is less than x is less than infinity. Make sure when you're doing this that you do have that x in between the two values, because x is kind of telling us what that value can be. So x can be between -2 and infinity. Let me know if you have further questions.